All right, so today I'll be going over the assignment that's about exploratory data analysis over a data set of our choosing. So the data set I chose was one regarding gym members and various characteristics and statistics of those gym members, such as the height, their weight, types of workouts, calories burned, etc. Um, so first, I wanted to make sure I cleaned the data set to make sure there's no missing values. And as we can see here, they all show to have no missing values before it was cleaned. So um, even though it was there's code there to remove any missing values, even though we didn't need it. And also some of the names are kind of off. Like for example, there's underscores between max and BPM and average BPM, but then there's not one for weight and height. So I kind of just renamed these columns just so it's easy to refer to them in code, and also that they're consistent. And then from there, I can also describe the data set, so we can get things such as the mean, the standard deviation, the range from the minimum to the max, things like that. So as we can see, the average gym member that was sampled was 38 years old. They have an average weight of 74 kilograms, average height of 1.72 meters, and the average gym member burned about 905 calories, works out about 3 days per week, and has about a 25% fat percentage. And then, but it also shows that there's a wide range in the weights from as low as 40 kilograms all the way up to 130 kilograms. And then there's also a wide range in the amount of calories burned, which is 303 calories all the way up to 1,783 calories. So this shows that may potentially be outliers. And then, so in order to get a further investigation on how these characteristics might correlate with one another, I built a correlation matrix, and then from there did a heat map of that correlation matrix to get a better look. And so we can see how all these various variables correlate with one another. Some ones of note were the weights and BMI, which is a 0.85, which shows a high correlation. On the other end of the spectrum, we can see a large negative correlation between the experience level of the gym members and their fat percentage, indicating the more experience they have, the lower fat percentage they tended to have. But so for this assignment, it was to build a regression model. So I was looking at the variables, and then I was seeing what type of independent-dependent relationship could we find between variables that would be useful and interesting to look into. So I decided to look at the calories burned right here with the workout frequency, and this indicated 0.58 correlation. So this shows there is a moderately high correlation between the two. But in order to go further, we need to look at the histogram of the calories, just so we can see how there's the distribution of these calories burned. And then also we can do a box plot as well to look at the relationship between the calories burned and the workout frequency. So here's the histogram. We can see a slight right skew, indicating that there were a few members who burned a much higher amount of calories compared to the most other members. And then we can also look at the box plot. We can see here the median number of calories burned increases as the workout frequency increased. And there's also a presence of some outliers at the top end, indicating that some members, very few amounts, may burn more calories than others, and this could be due to other factors such as like the intensity of the workout and things like that, and the types of workouts they did. We don't have to, and so in order to also do this regression model, there are some assumptions, such as there has to be a linear relationship between the independent and dependent variables. In our case, the workout frequency is the independent variable, and our calories burned is the dependent variable. And then there also should be homoscedasticity and normality of the residuals, and no multicollinearity between the independent variables. We only have one independent variable, so you don't have to worry about the multicollinearity. However, we do need to look at the homoscedasticity and normality of the residuals, which is what the next step was. So I did a Shapiro-Wilk test. This indicated that that the residuals do not appear to be normally distributed, and the homoscedasticity was tested with a Brush-Pagan test, and this, on the other hand, failed to reject the null hypothesis that the residuals have constant variance. And this can also be further looked at as far as the a QQ plot of the residuals. And we can see here we're looking for our plots to follow this red line here. It's about a 45-degree angle. And as we can see, most of the data points do follow that the line here. However, there are some increases on the both tail ends of the plot. So this shows that there isn't a severe violation of normality of the residuals, but there is a slight normality violation. So in order to address this, I did a robust model to kind of account for the since we violated one of the assumptions with the as far as the normality goes, and then I also from there did a summary of the now robust model regression. Some things of note to look at were the R-squared value of 0.332 right here indicates that 33.2% of the variance in calories burned is explained by the model. The F statistic has a very low p-value, indicating that our model is extremely significant. Has extremely significant predictive value. And then we can also see here the coefficient of the workout frequency being 172. This indicates that for every additional day worked out, increased the amount of calories burned by 172 calories on average. And also from there we wanted to test the strength and the direction of the linear relationship between the amount of calories burned and the workout frequency. So from there I did a Pearson correlation coefficient test, which resulted in a p-value much less than 0.05, indicating that significant linear correlation exists that we should reject the null hypothesis. And then this all goes to show that through these various methods of testing and investigation, that there is a strong positive correlation between how often one works out and the amount of calories they burn. They increase more calories burned per session. And that was found, numerically found as 172 more calories burned by each day increased of working out. And again, of note, this is a correlation, not a cause and effect relationship between the two variables.